This is the programming system for WebProLogger, and at Torbjorn.
Hello, everybody. So nice to meet you, or whatever you say when you're online like this. So I'm going to switch over to my PowerPoint presentation. Hang on. So share screen. Right. And there you go. So
we're not seeing your PowerPoint.
You're not seeing a PowerPoint? All right. Oh, good. So WebProLog and a programmable Prolog web, an attempt to revive Prolog. That's the title I've chosen for my talk today. It's actually also the title and the subtitle of the manuscript that I'm working on, where I try to explain the ideas behind this proposal for a new programming language called WebProLog, and an extension of the traditional web with Prolog, which I refer to it as the Programmable Prolog web. All right, so as Anne mentioned, I sort of is the person behind Swish. In 2013, I wrote the first version of Swish and presented this as an homage to SWI Prolog, which had its 25th birthday that year. I also wrote web applications using Prolog as a backend, and that became library engines. But it didn't become library engines until I went down to meet Jan Willemaker in Amsterdam, the guy behind SWI Prolog. And since he liked what he saw, we started to collaborate on this. And down there, I show the title of our first publication, Engines WebLogic Programming Made Easy. There's another publication in the works which describes Swish. It should be published in the Theory of Practice of Logic Programming quite soon now, I think. Okay, so I should be happy, shouldn't I? I am, but not 100%. Because I think being able to talk to Prolog from a browser is nice, but there are other things that I think Prolog on the web is able to provide us with. And that doesn't really work in library engines in SWI Prolog at the moment. And it's due to the design of the library behind Swish, library engines. It doesn't quite fulfill my expectations. I confess that I made some design mistakes, and I really would like to try to correct them. So some 2 years ago, when Swish and engines already existed and worked well, not as well as Today, though, since John Villemaker has improved it a lot over the years. But 2 years ago, I was inspired by the Erlang programming language, where I found a much better approach to something like library pages. But I kind of thought that the approach was so nice and the idea was so beautiful that I decided to try to design a new language rather than just a library. And that's WebProLogger, of course. And in addition, I kind of saw that as a way to try to help solving what I will refer to as the crisis of Prolog. I tell you, I love Prolog. I started using it in 1986 when I began my undergraduate student as in a program for computational linguistics here in Gothenburg, where I still work. But I'm also over the years seen that the popularity of Prolog has decreased a bit, and except for the most recent year or two, it's going up again, but not as in the good old days in the mid 80s to the year of 2000, something like that. So just a few short words about Prolog first. Yeah, I've already said that it used to be popular 1980 to 2000 roughly, with applications in artificial intelligence, knowledge representation, expert system, computational linguistics, etc. And you already know that. I don't need to show you, but you may not be aware of the crisis of Prolog. Here's a quote from Tom Schriviers or something like that. I probably don't pronounce his surname correctly. He wrote in an Association for Logic Programming newsletters some 10 years ago. In the 6 years that I have been doing research in the logic programming community, I have met a lot of nice people and heard about a lot of interesting research ideas. However, the community itself isn't exactly thriving, and the logic programming has a serious PR problem. It's my fear that if we happily continue along our current path, then there will be little left of logic programming and its flagship Prolog in a couple of years. Well, things have improved since then, but not by very much. I have another quote here about the crisis of Prolog. I'm not going to read that out loud for you, but people complain about the Prolog community being fragmented. And there are far too many incompatible Prolog systems around, and they each have like a sort of sub-community. Surely SWI Prolog is the biggest community. There's no question about that. But there are others, and there are some commercial and some others. And then there is this, here's a list of the plethora of Prolog systems, and the list isn't complete. Someone said in a news group not long ago that he could only count to 4 of these implementations being updated in the last year, but some of them are certainly around. It's not so strange because there's still quite a lot of research going on in the logic programming and Prolog area. And there is, for example, XSB Prolog, which has a really good implementation of cabling. Maybe Anne or someone else has told you about cabling already, I don't know. But it's a very nice functionality that allow you to program in a more declarative way. So different Prolog systems are good at different things. So wouldn't it be nice if different Prolog systems could sort of talk to each other using a language? WebProLog, that's my proposal, that different Prolog systems should use WebProLog to talk to each other. Well, I'm not going to say all this, but there's an ISO standard for Prolog. The problem is that it's too small, and some people think it doesn't make the right decisions in certain ways, so the different system doesn't really conform to the standard. All right. The web. So I love Prolog and I love the web. That's why I'm trying to combine the both into something interesting. The web, as you know, I will just remind you of a few things that will come up later. It's the biggest distributed programming system ever constructed. It's no question about that. It has billions of daily users and millions of contributors. It's decentralized and open by default, although there are well-known problems about around that. But as an ID and as an architecture, it's decentralized and it's also open. So as a consequence, I read in a report from Stack Overflow, as a consequence, JavaScript has become the most commonly used programming language on Earth. And in this report, it was even stated that even back-end developers of web-based systems are more likely to use JavaScript than any other language. It's also a characteristic of the web that it really needs standards for portability, but also for interoperability, the ability to systems to talk to each other and do what they are supposed to do. So WebProLog. I have an elevated pitch for WebProLog. Let me drink some water and I will read it out for you. Imagine a dialect of Prolog with actors and mailboxes and send and receive, all the means necessary for powerful concurrent and distributed programming. Alternatively, think of it as a dialog of Erlang, which is another programming language, with logic variables, backtracking search, and a built-in database of facts and rules. The means for logic programming, knowledge representation, and reasoning. Also, think of it as a web logic programming language. This is what WebProLogger is all about. Okay, so I have to tell you something about the Erlang programming language, which, as I've already explained, has inspired the design of WebProLogger a lot. Erlang was invented by Joe Armstrong, Robert Virding, and Mike Williams in the second half of the 80s. It was invented within Ericsson, the Swedish telephone company, but the language was released as open source in 1998. What's special about Erlang is that it is probably the most well-known actor programming language. and it's famous for concurrency and distribution. Another interesting thing about Erlang is that it has its roots in Prolog. They sort of designed Erlang by taking Prolog and removing a lot of stuff. Among that, its character as a relational programming language and as a non-deterministic programming language. But they also added some really important things that are good for concurrency and distribution. And the actor programming features. And then, all right, so I also like to say that it's currently much more popular than Prolog. It's easy to see if you look at the different sites which try to rank the popularity of different programming languages. So to the left here, we have two Prolog programs. One predicate determining the length of a list, and a program for reversing a list. And to the right, you can see the corresponding Erlang programs. You kind of see that they are related, don't you? Except there are some funny things going on. But if you look at, just like in Prolog, variables in Erlang is written with a capital letter first. Lists look the same. There's pattern matching going on in both languages. And there's recursion going on in both languages. The difference is clear here that Erlang, though, is a functional language. You see the kind of nesting you can do in a functional language going on here. So again, on the road from Prolog to Erlang, the designers of Erlang sort of removed some stuff from Prolog in order to arrive at Erlang. They removed the built-in backtracking search. They removed unification. They still assign once variables, immutable variables in Erlang, but no full unification. And pattern matching is just one way in Erlang, while unification can be described as a two-way pattern matching. So they can't really do any logic-based knowledge representation, no reasoning. They don't do any meta-programming. They don't have any user-defined operators, no term expansion mechanism. And of course, there's no definite clause grammar. So, they made the language functional because they thought that the customers, also the developers doing development for Ericsson, they thought that it would be easier for people to learn a functional language. And that's probably correct. Prolog, as some of you may have felt already, has a rather steep learning curve, but it's worth it. I hope you think. All right, and more importantly, the designers also added actors or concurrent processes which allow you to do really, really efficient concurrent programming and distributed programming. Sorry, Anne, did you try to break in?
No.
Okay, I just go on. Here's an actor, the idea here. An actor is the fundamental unit of computation in both Erlang and WebProLog. So it's inside, it's a process basically, and which is sequential internally. So there's no, well, there could be concurrency going on internally too, but it's basically sequential internally. And it has isolated memory. It doesn't share memory with other processes, with other actors. It has a unique name or a process identifier, a PID. You can use this PID in order to send messages to the actor. The PID is used as an address. Messages are received, they end up in the mailbox of the actor, which is basically a queue. And there is a receive function in Erlang and a receive predicate in WebProLog that you can use to sort of listen for messages, matching on messages that are in this mailbox. And if there are no messages in the mailbox, the receiver will just wait until one appears. It could also time out sometimes. An actor can not only receive messages, it can also send messages. It could send messages back to the process that may have spawned, created the actor process from the start, or it could send a message to any actor. It needs the PID for it to be able to send a message, but once it has it, it can send a message. And it could be a local actor or it could be a remote actor. It really doesn't matter. An actor is also able to spawn, to create other actors. And the only way two processes, two actors can interact is by sending each other messages. So it's done in an asynchronous way. You just send your message, but you don't wait for any response coming back to you. So this is how you write a simple example in WebProLog. This is a ping server. So here's the code for it. And it's all Prolog. But this thing is a kind of, I guess you could call it a MetaPredicate. Yeah, that's a kind of MetaPredicate, which has in this case only one argument, which holds an ordered set of receive clauses. And this receive clauses is sort of waiting for a term, a message term ending up in the mailbox of this form ping. And if it receives a message of this form, it's going to send back a pong to this PID in the variable from here, and then recurse. So do it again. And to the left here, to the right, sorry, we spawn this process, and we get the PID, and then we need, in this case, to find out the PID of the current process, the process running this Prolog top level here. And we get that too. It has its long name here. This is just a random identifier and his URI. And what we do next is to grab the value of PID here. This is a special notation. I'm not sure you've been introduced to it, but this is just a utility that you have in the shell only, so that you can pick up the value of the variable that you used up here. So you can use that to send a ping message, and you get the from, which is going to end up as from here. You get that from picking up the value of self. And then you have another utility predicate, which is also present in Erlang, called flush. If you execute it, it will always terminate, and it will do so after having printed out all the messages that are in the current, in the mailbox of the current process, which is the one running the top level here. That's actually a penguin. I get to penguins later on. Now, suppose we want to spawn this process not locally, but on a remote server instead. Then we use two different options that we send, that we pass to the spawn predicate. The node options just identifies, using a URI again, identifies the node on which we want to create the process. And then the source predicates option, it takes this code here to the left and brings it over to the remote node. Okay, so we get the PID for a remote node. We do the same as we did before with self. We send it and we got the POM. So that's, I actually think this is nicer in WebProLog than in Erlang, but you can do similar things in Erlang too. Now, the actor is as I said, the fundamental locus of computation in WebProLog. But on top of actors, we can build engines. I show you how to do that in principle. And on top of engines, we can then build something that I refer to as non-deterministic remote procedure calls. I think Anne told me that you've been doing something with engines, and maybe you used engines RPC.
Torbjorn?
Yes?
Yeah, we're running a little behind in replies.
Okay.
And we're just now getting to engines, so
All right. That's all right. I just wanted to say that I just call it RPC, but it's basically the same thing, except for some crucial things. Okay, so, but if you have actors and want to handle non-determinism, how do you do that? Is there a nice solution in using the kind of constructs that I've shown you so far, constructs for sending and receiving messages and for spawning processes? Yes, it is, and there is a nice solution, and the idea behind it is shown in this program here. So let's assume that we have, the ancestor, the descendant database, which I'm sure you've seen at some point, where you can a non-deterministic programming where you can which you can query in different ways. Now, what's going to happen here when we spawn this program here, right, between those parentheses, is that this query is first is leading to search, and it finds a binding for the variable who, and then picking up self from here, we send to the PID self the value of who, and then we wait. We wait for a message of the form next to show up in the mailbox. And we are going to fail. And fail, is a built-in Prolog predicate that always fails. So what's going to happen then? Well, the semantics for the receive predicate tells us that in this case, receive fails. It's actually the only way in which receive can fail is if the right-hand side of the arrow here in a receive clause is failing. So if receive is failing, then we're going to backtrack and find another solution to this query and bind who to another value, send it, etc. So that's what's going on here. So the first solution we could find, we could see using Flush was Tom, and then we sent to the PID of that process. We send the message next, and then if we flush the mailbox again, we get another value, Sally, and then we can send stop, and in the receive clause here it says that stop should lead to sending stopped to self, and we see by using this construct here, message is bound to stopped. So if you want, if you kind of want to really try out WebProLog, you should download the current proof of concept implementation. I think I forgot to add a URI to it. It's on GitHub. But you can just search for WebProLogger, and I think you find it.
I'll put it in the class material, and I'll add it to the recording of this video.
Yeah. You see, if you download and try out the tutorial, which is part of this proof of concept implementation, which, by the way, if John helped me immensely to get this in order. But
John,
still,
is that John Soa?
John Willemacher.
Oh, Jan Willemacher. Okay.
Yeah. He helped me a lot in the implementation phase of this. But there is a running implementation. There are some bugs, and it's not safe or stable enough to run online, but you can run it on your own local computers and have fun with the tutorial. The example you show here, I just shown here, you can very easily run those, and you can also choose to get a less attractive editor than in Swish, but a usable editor, and you can write your own programs and try it out if you want. All right, so I showed you in the last example how to program search or non-determinism in the system. But it was kind of hard-coded. The query was hard-coded into the program in a not so nice way, and the program wouldn't work if the query failed, or if it failure would work, but no, it wouldn't. No, not even failure would work in that version, and error handling wouldn't work either. So here's a somewhat better version where the query isn't hard-coded into the program, and it's able to distinguish between deterministic queries and non-deterministic queries, etc. But you don't have to do. You can do that. You can program your own generic encapsulated search in WebProLog, but you don't have to do that because there are engines, Prolog engines in WebProLog as well. And the engine is actually only a special kind of actor characterized by a particular communication protocol. So the protocol is to the right here. I don't think I want to go into the details. You have to read my manuscript or play with the implementation. But it basically, as a protocol should do, it basically tells any client what it can do in each phase of a conversation with a node or with the engine running on a node. You can ask a query. You may receive a success message or a fail message or an error message. If there are more than one solution to your query, you may receive a particular kind of success message that allows you to send a request for the next message, etc. So the idea here is that a penny becomes a completely generic encapsulated Prolog session, a whole session, because you can ask a query, and you can, in this query, update the dynamic database, and then you can, in your next query, do something with the updated database. If a query goes into infinite loop, then you can abort it, etc., etc. The notation here, unless you may not be familiar with it, but it's a state chart. It's a particular way to draw kind of state machine. All right. So how do we work with engines? Well, there's not only a predicate spawn, but there is also a engine spawn in WebProLog. And it also takes options, and it takes many of the options that spawn takes, because engine spawn inherit, I think, all the options from the actor, from spawn. But it also adds a couple of new ones. I won't be able to show you all the options. You need to read documentation or play with the tutorial for this. But Penguin Ask, where you can send a non-deterministic question, query, it takes the option template among several other options, limit or format or what have you. But the idea here is that if you have done this, if you have spawned a penguin and then sent it a query, you will, as you can see here, in your mailbox, you will get, in this particular case, a success term coming from this PID, you can see here, and a list of solutions to X. And true here tells us that... Hey, Torbjorn? Yes?
Yeah, I just wanted to caution you about time.
We're running out of time. Are you saying that?
No, I'm saying it's 41 after.
Yeah. Okay. So do I have like 15 minutes more?
Yeah,
or?
Of course you do. Yeah.
Okay. All right. Okay. So I'll try to speed up a bit. All right. So, and we can, after we have received that, we can send, we can request the next solutions. We can set the limit option to 2. If there are 2 solutions, we will get them both. And in this case, there are. And false here means that, all right, there are no other solutions to the query in question. Now, on top of penguins, we can build non-deterministic remote procedure calls, predicate for doing that. And I show here 3 different uses of it, different options given to it. In this case, we just ask for the solutions to P of X here. We get A, B, and C. But we do this on a remote server, okay, on this server, in the Prolog context of that server. So that server probably has then P of A, P of B, P of C. In order to do this, it has to make 3 network round trips to the node, or the server, the node. And that's very inefficient, of course, because network round trips takes a lot of time compared to other things you do in a program. A way to sort of optimize the queries without any discernible effect in the solutions that you get, or the way in which you get them. We can use limit. In this case, we set it to 10, and it will still, in the same way, produce the same solutions. And it needs only 1 network round trip to do this. Now, in some cases, we may choose instead to download from the client, download the source of the predicate that gave us this solution and run it as local node here, which is the default for RPC. So it means it runs locally. So remote procedure call is kind of a misnomer, but it doesn't really matter. And in this case, it needs only 1 network round trip to.
Torbjorn?
Yep.
So I have a question about that. You might want to go back
to
the last slide.
Oops.
So, local node.
Yes.
Obviously, if the point of running has access to a resource, like the remote server is a weather station that Clearly, it's not going to work to run it on my local server.
No, exactly. I should have added that it has to be WebProLog source only. In this case, we need to assume that it's only WebProLog, pure WebProLog source code.
Well, yeah. So my point is that don't you break encapsulation? This often seems to be the problem with distributed systems, is that they don't end up addressing the realities of the situation.
Well, I can interpret that question in two ways. So let me see. Are you worried that if you sort of download the source to the local node, that you will sort of mix with other definition of P with one argument?
No,
That won't happen.
My concern is that P might download P. P in turn might, for example, depend on calling my, if it's practical, then P has to somehow interact.
Well, in some cases,
I use the example of interacting with a weather station hardware, because, more frequently you run into the situation of like a database or another server internal to the system. Facebook does not want to send you their entire, their entire database. So that you can run a query.
Yeah. You're certainly right, but not all programs need access, need to interact with the surrounding world. There are, take lexicons, for example, encoded in Prolog. They can be downloaded instead of. And if it's large, it might be a good idea to download it instead of and run queries on it, rather than to make all those network round trips. So, but surely in some cases this won't work, but as a developer you have to find out. You might find out the hard way that it doesn't work.
Yeah, that's always seems to be the element is abstracting away the network is not necessarily valuable abstraction, because the network's something in the real world.
Yeah. You're certainly right. It will work only in certain cases. So I'm not sure. Maybe I shouldn't. Maybe I should stop there. You have any other idea?
Do you have more slides?
Yes, I do.
Hey, okay, and I have a question from a student, from James Cash. If the remote URL will work other than just trying it, which is a good question.
At the moment, no, it's not part of the current design, and I'm not sure, to be honest, if it's needed or not. But I mean,
you have met the engineers, and they are us.
Yes. But you have to think about it in this way. I think that at least in the beginning here, you and, for example, you might want to decide to run a node, your own node on a server somewhere. And then you can choose to make the source of your full system available through this URI.
This might be another reason, is that source might be proprietary.
Exactly, but you see, what I call the node resident WebProLog source code, it will reside in a particular area in the node. All right, and it might import stuff from the runtime environment, which isn't necessarily Prolog even. It could be a WebProLog implementation in Erlang. And but the thing is that in this particular partition in the node, only the source, only WebProLog source is permitted. So that's what you're going to get. But you can also choose to only show if the you can easily that's the idea, stop people from any interesting information when they download this code. And in this case, of course, you won't be able as a client to compute with it. But it's your choice as the owner of a node how much of the code, the WebProLog code that you store on your node that you want to share with others. But I think it's, I mean, for a web programming language, for a web logic programming language, it makes sense, I think, in many cases to actually reveal the code. You do that with JavaScript, and that works, doesn't it? As long as you can hide it.
I agree, and the issue of proprietary.
Yeah.
All you get is the code that, I mean, but at some point then, either that's got to talk to other code that is not, you know, I mean, JavaScript, of course, you're running it locally all the time, and it was designed to run locally, but then, then the JavaScript, when it needs information from the system, does an AJAX call, and call or whatever, but you know so ultimately, you know, for example, quite frequently, you know, that call may even then call something that's only available on their local network.
Sure, and in this case, this won't work, this use of RPC with a local node. But the fact that it is a program that accesses a thermometer or something like that should be documented anyway, shouldn't it? So if you try to download and use that locally, it should be.
I think we're wondering if that doesn't need to be something that's knowing whether or not local node is acceptable.
Yeah, that could absolutely could be that. Those are, I mean, the design of WebProLog isn't finished yet. I'm working on it. I'm really happy with what I have so far. I think it's a beautiful programming language. the features that I borrow from Erlang, they are great, I think. And I think the idea of having a web Prolog as a web programming language is very interesting. It will simplify a lot of things.
Oh yeah, I think we're all just just
Yeah.
notice this one.
Yeah.
Okay, is that your last slide?
It's not, but we can stop there.
I have questions from the audience before we wrap. Thank you. So I will post the links.
Oh,
Torbjorn,
good.
if you want to send. No questions. Great presentation. Thank you from Jason. And yeah, I will post all the links. Thanks for the presentation.
Thank you very much. And if
go ahead.
so, yeah, if any is interested enough to try out to test drive the proof of concept and the tutorial, I would be extremely interested to get some feedback on that. And if you care to read what I've written, of course, I really need, I'm in at a stage now where I need a lot of feedback. I've had some nice feedback from Joe Armstrong, the inventor of Erlang, by the way. So he really likes it, and I'm glad he does. So
yeah, Joe was talking it up on Twitter.
oh yeah. I've been chatting with him as well, so we've been having a conversation about stuff like this.
Yeah, it's an exciting. I love this.
Yeah. Yeah, yeah, they are really nice. I mean, the intuition and the programming model makes a lot of sense, and I think a language like WebProLog succeeds in combining the logic programming model with the actor programming model.
I have a question for you, I guess.
Go ahead.
Actor programming model where you have to have the mailbox address
Yeah.
from an agent model where you broadcast sort of into the void.
Yeah.
Is there a reason for choosing actors instead of agents?
Well, you can not really, but you can certainly write the agents, as you call it. You can write that very easily in WebProLog. There's a publish and subscribe example in the tutorial, which you can have a look at if you want. And that's basically what it's all about.
Yeah, that's basically PubSub.
Yeah.
So,
Mm-hmm.
yeah, I'm making a robotic snail.
Yeah.
Yeah, it's
Uh-huh.
okay.
All right.
All right. Thank you very much. This has been fascinating.
No, thank you. Have a nice day. It's
Hey,
getting late.
and to all our students online, I'll Slack and uh, thank you very much, Torbjorn.
Thank you. Thank you. Bye-bye.
Bye.